Hey everyone, welcome to my daily coding series. Today is day 56. So I'm going to look at another stack problem here. So I failed this one last week. I didn't look up the solution yet. I've been pretty busy, so I'm just going to try this next one. Daily temperatures. So I haven't looked at this. You're given an array of, so a list of integers temperatures where each one represents a temperature. Return an array result where each one is a number of days after the ith day before a warmer temperature appears on a future day. If there is no day in the future where a warmer temperature will appear for the ith day, set it to 0. Okay. All right. So temperatures is a list of temperatures. The output is asking at this index, how many warmer temperatures will appear at this index, right? Result of I is the number of days. Oh, no. It's not how many. It's how many days until a warmer day will appear? How many days until a warmer day will appear? And this is temperatures. Okay, so how could we go about doing this? So my initial instinct would be to start from the back. So this might be similar to like the min stack problem before. Okay, so maybe we have 28. So this at present is the largest temperature. So we know that this one has to be 0 because 0, there's no possible way that this could have a warmer day after because it's the last day. So right now our current warmest temperature is 28. Then 40. So because 40 is greater than the top of the stack, it's also 0 because it's the max so far. 35. So 35 is less than 40. So that means there's 1 day until it will appear. So I'll just add it here. I don't really know if it's necessary. Okay, 36. So maybe now we continuously pop from the stack. Well, All right, what if we have 2 stacks? So we'll have 28. So this will be like the max, and this will just be everything. 28. Then we have 40. So 40 gets added here. 35 does not get added here. So we need to know, like, for this problem, or for this. So for 35, how many days until there's something greater? So do we just like keep popping from the stack until? But I don't think that is really true because we need. Maybe it is true. Maybe it's not. Because if we have, let's say, 36 after, which we do actually, you can't remove the 40 because this needs to detect the 40. All right, before I worry about stacks, let's just think about how I'd actually solve this problem. So we have 30, 38, another 30, 36, 35, 40, and 28. Okay, so this one, no matter what it is, so we'll set our max equal to 28. This reminds me a lot of another problem that I did where you had to figure out like if it was in a range. Okay, so 28 is our max. And we know that 28 must be 0. 40 is greater than our max. So if it's the biggest number we found so far, then we know it has to be 0. 35. So we could, I guess the naive solution would be check each one until you get something bigger. So here we get this is the first biggest one, so we'll do 1. 36, it's not 35. 40 is, so we would put 2. 30 would be 1. 38 would be 1, 2, 3, 4, and then 1. So that would be the trivial solution. That's n squared. Where basically you have to see how many steps ahead until I get something that's bigger than me. Maybe we could store like the index in the stack. So if we have, let me index these. So if we have 0, 1, 2, 3, 4, 5, 6, maybe not even a stack, but okay. So we have 28 at index 6. And then, hey, 40 is the new max. So like we don't actually need this information at all because anything that's less than 28 will also be less than 40. So we can remove that. So whenever we find a new max, 40 is index 5. 35. So now this is where it gets interesting because 30, like if 30 was here, even though 35 is not the max, it still should look at that one. So 35. So this would just look at the most recent element. So $35. All right, let me simplify a test case. So if I have 40, 35, and 30. Okay, so the answer should be 0, 1, and 2. So my question is, how do I get the max, the closest thing above 30? And this is, I remember, where you could do like a binary search. Of these, and then that solution would be n log n. But I don't know how you could use a stack. So what I mean by that is like, well, I don't actually even know if you could do a binary search because it's not necessarily even sorted. No, yeah, you couldn't do a binary search. I'm honestly just really stumped off the gate. Maybe I should just start by implementing the trivial solution. I don't even think you have to go backwards for it. So yeah, so we just have result, and then we'd say so we'd say like num equals temperatures of I, and then while, and then we'd set, I guess, so like j or days is equal to 0, while days is less than, well, days should actually be set to I, while days is less than length of temperatures, and num is greater than, so while it's greater than or equal to days of I plus equals 1. So it'll keep going, and then eventually when it's no longer true, we can return, so result of I would be equal to days. So if I return result, let's see if this works. Days of I, days is an integer. Oh, this part is incorrect. It should be temperature of days. All right. And then this should be days plus equals 1. Range. Yeah. So it's out of range. Is it because maybe I could say result dot append, because this is an empty list. 1 5 3 5 5 7 7. All right, that doesn't make any sense. So should we reset it to 0 actually? But this won't work. So I think we have to say while days plus I. Okay, so mine says 5. So if we print 1, 2, 3, 4, 5. So this one is 1. This one, so days is 0. Yeah, so why does days... Maybe we should say j equals I, while j is less than, and days equals 0. J plus equals 1. So I have a 2 and a 1 here. Yeah, that would make sense. So this looks good. The only problem is I'm just returning on how many indices it takes to get out of range. If j equals length of temperatures, then res dot append 0. So if there is nothing, yeah, okay. So that would be the trivial solution. And it's O(n) squared. So with the stack, okay, this is an interesting test case actually, the second one. 22, 21, and 20. Interesting test case for sure. So what if you add to the stack? So we know if you're 19, if 19 comes here, and there's nothing less than you in the stack, maybe we can look at it that way. But we need this answer. Okay. So let's imagine we just have this. So let's go backwards. So you have 20, then we add 21, and then 22. If we had, for instance, 18, we could see that the first element of the stack is greater than. So how can we use a stack? Because this is really just the same as a list. Because, all right, let's say we had 18, but then let's suppose we had 19 after. 19. So in the case that we have 19, yeah, so there's like two possibilities. So there's this. Honestly, I don't even need the rest of the stack. 18 and 22. Okay. So there's two possibilities. So there's this possibility where each element is just bigger than the other, but then there's also this. I mean, we could sort it. No, we can't. We can't. Or could we actually? No, we can't. We can't. So this one. So how can I instantly know that the next biggest one is 22? So that would mean we would just want 22 on our stack. But in the case that it's 17, we need to instantly know that 18 is the next biggest. So how could we add? So this type of problem is like, hey, I need to know the next biggest thing and where it is. That's basically what it's asking. Like, how far away is the next biggest thing from me? How far away is the next biggest thing from me? And we can use a stack somehow. Yeah, so this code where, or this example where it's all increasing, so 22, 21, and 20, or decreasing, I mean. So this is not possible, not possible, not possible. In the case where it's all increasing, then everything is 1. So this might give us hints. In the case where it's mixed, like 5, 7, 6. Well, actually, this one is always 0. This one is always -1 no matter what. So maybe if we look and there's an empty stack, we can say it's not possible. Then add it to the stack. This one is bigger. It's so tricky because we need both this information. We need 6 and 7. Do we have another stack? But then it's like, how does this one know which one to even check? I mean, in this very specific case where 6 is right next to 7, you could just get rid of, well, not necessarily, because if you had another 6. So with the min stack problem, we only added, so we had our normal stack, right? And then we only added things if it was smaller. Can we do something similar with this problem? Or maybe it's like better, it's not linear maybe, but maybe it's better than n squared. So here 20, it's empty, so 20 is the smallest we've seen so far. 21. Let's go right to left. So 22 is the biggest we've seen so far. Actually, it makes more sense to go right to left, because we know that this will always be 0. So 20, and then we need something less than it. So if it's less than it, we have an answer, but if it's not, then we add this. So in this case, okay, this is interesting. So if we have 17, actually, we don't need, I think maybe I was making a mistake, because if we have 17, we don't actually need this 20 anymore. We don't need the next biggest thing. We just need how long is anything that's bigger than me. So with that distinction, we don't actually need 20. So we can replace 20 with this, because anything that is less than 20 will also be less than 21. So we can store its index, let's say. Okay, so we know the first element in the back will, so let's say it's index 2, right? This one has to be 0 in the result array. Right, okay. So in that case, so this is our stack. Okay, so then we encounter something that is bigger. We encounter something that's bigger, 21. So 21 also is 0, because the top of the stack is smaller. So because the top of the stack is smaller, we can add it to the stack or delete it, I'm not really sure. Now anything that's, we don't need this 20 anymore. Is that true? We do not need this 20. What if it was 5? Do we need this 5? No, because anything that would need this 5 would first be interrupted by this 21. Okay, so now we're getting somewhere. If it's less than 21, so like 5 or 4, it would catch this. If it's bigger than, then we would add it to the stack, like 30, let's say 0. Right, okay, so this is starting to look good. So we'll start from, so I'll just comment all that out. So we'll start from the back, not muted still. Okay, so for I in range, length of temperatures, -1, -1, -1. Okay. So we want to check, so we'll have, and maybe I'll start from the second one, because we know, so we know that the result, so I'm going to make it, I don't know, let's say -1 times length of temperatures. And we know that the last element has to be a 0, and then our stack has to include the last element because it's the biggest that we've seen so far. So we would include in our stack, I'm just going to put the value, so temperatures of, so the last element and its index, which is length of temperatures -1. Okay, so then there's two cases. So if temperatures of I is greater than, if it's greater than the top of the stack, if it's greater than the top of the stack, then that simply means it's impossible. Like there's nothing greater than this, because we'll assume that the topmost element in the stack is the max. So we'd say result of I equals 0. Otherwise, what if it's equal to? Then I think that also should be 0, because if we have a bunch of 30s, let's say, so if our array is 30, 30, 30, this would be 0. This has no warmer temperatures, and this has no warmer temperatures. Yeah, so it's greater than or equal to would be our fail case, so to speak. All right. Otherwise, if it is greater than the stack, or if it's less than the stack, I mean, we would say, first of all, okay, so this, if it's greater than the stack, we need to add it to the stack as well. So we would say stack.append temperatures of I and I. So just the tuple. Otherwise, so if it's less than the stack, so is it ever possible that there's a closer index? No. So if we have like 5, let's say we have 5, 7, 10. So 10 is 0. I'm going to move this stuff down. Okay, so 10 is 0. And then our stack becomes 10, 0. 7 is less than, so what do we want? Because this is less than the stack, we want to say that's 7. So 7 should go so it'll just be the top of the stack minus, yeah, so it would just be 1. But now the problem is here, so we don't update the stack because this wasn't bigger than the top of the stack. So 5 will look at the top of the stack and it will return 2, but the answer is really 1. So it's precisely in this case that will fail. I'll still code it anyway. So we want to get the, so if it's smaller than, we want to say that result of I equals, because this is a tuple, right? So result of I should be equal to our I value. Well, I guess it would be the top of the stack's I value minus my I value. And then I guess, yeah, I guess this would be it. And then we'd say, so this will be false for sure. It will not work. So 0, 0, 1, 2, so 3, this is the first error. So this one, and that makes sense. 1, 2, 3. So everything is pointing to the max. So we could have on our stack just like, I guess 30. I mean, we could add the 7 and then just keep popping until we get to something that's greater than, but isn't that just the same exact thing that I already coded down here? I think maybe that's what you're supposed to do, is just add to the stack. But what if we had a 3? What if we had a 6? Okay, so I'm going to try doing that. So what if you always add to the stack and then just keep popping until you get, okay, so we'd have 10, then we'd have 7. So I guess we would just add it to the stack and then add this to the stack. Okay, so 10, because there's, you know, we that's our base case. We set results. So I'll have 4 elements. So we set it to 0. Then 7. How many times does it have to go to get to something bigger than it? Would be 1, 5. So then we add that to the stack. This is exactly what I did though, with the for loop. So is it just like more efficient if you start from the back? Because each one has like less to explore. I feel like it's the same either way. Yeah. Okay. Well, I have to go. Thank you guys for watching. Yeah, I'm not exactly sure how to do this one, but I'll look at the solution, and yeah, I'll see you guys tomorrow for day 57.